Welcome to our first experience in exploring the Spatial Analyst Toolbox. So, first things first, and this is very important. Spatial Analyst tools are an extension in ArcGIS. In order to get them to work appropriately and to not get an error message, you need to make sure that you go to your Customize, Extensions, and that Spatial Analyst is checked. I'm going to uncheck it and close and show you what happens when you don't check it. So I'm just going to pick the slope function, which we're going to get to eventually, and it says tool not licensed, unable to execute the selected tool. Do not panic. Do not panic. You just need to click OK, go to Customize, go to Extensions, and check the Spatial Analyst toolbox. And now if I open up the slope tool, it opens up. We'll get to that tool in a minute. End of the PSA. Okay, so do not email me telling me that you can't license the tool, because I'm going to say, go to the video and watch the steps for customizing the extension. It's okay. I'll answer your email. Okay, so let's go to Raster Calculator, because what we are going to do first is query the DEM and ask ArcGIS to query those 1.8 million grid cells and return a grid that responds to the query. We're going to ask ArcGIS to create a grid that gives us a 1, a true, if a grid cell is equal to or greater than 200 meters, and a 0 if it's not. So it's taking this beautiful continuous grid and returning a binary grid of just zeros and ones that answers the query. So to do this, we go to Spatial Analyst Tools, Map Algebra, Raster Calculator. And it pulls up a query box that's sort of similar to ones that you recall from Vector, but this is for Raster. We are going to take, very important, the DEM, because we can't do math on a DRG. And we're going to say lag DEM, double click, is greater than or equal to 200. And we want to give the resulting output raster a meaningful name with a meaningful location. So I'm going to call it LEV GT for greater than 200. So I'm querying my beautiful DEM, and I'm asking it to return a grid of zeros and ones, where it's going to be ones if it's greater than or equal to 200 and zeros otherwise. I'm going to click OK. And voila! I have a grid, a binary grid of zeros and ones. And for clarity, or just for better symbology, I'm going to go to the properties for LFGT 200, and I'm going to go to symbology, and I'm going to select the 0, double click it, and just say no color. It doesn't mean the zeros aren't there. It just means that they are no color. And I'm going to hit apply and OK. And anything that's a 1 means that it's greater than or equal to 200 meters in elevation. I'm going to open an attribute table. I actually have an attribute table. Why do I have an attribute table? I only have an attribute table because it's an integer grid. If I try to open an attribute table for the original DEM, lag DEM, there's no attribute table because it's float. It's an integer grid. It gives me an attribute table. It tells me the count. This is important. The count, the total number of cells that meet that criteria, are 286,847 grid cells that are greater than or equal to 200. I'm going to make sure that's not selected. And what if I wanted to find out the area that meets that criteria? What do? Remember from the first exploration, the exploration of the DEM, this is the total number of cells that meet that criteria. If we multiply that by the grid cell resolution, that gives us the total area in square meters, and we divide it by 1,000 by 1,000 so that we convert that to square kilometers. So I will let you do that on your own, but here you have it, a binary grid with the elevation greater than or equal to 2,000. If you wanted to further clarify this in your table of contents, you can change the name and call it High LEV or something like that. And we will hit apply Okay, and stay tuned for the next step.